Hello, pre-calculus students, and welcome to our continuing series here on the mathematics of finance, and more specifically, what this has to do with logarithmic and exponential equations. So we talked a lot about annuities in the previous videos in APY and APR, and here we're going to look at a concept that's called future value and present value. So 3 says, to buy a house, you borrow $80,000 from the bank today with an APR of 4% compounded monthly. What is the present value of the loan? Well, the present value is just how much is it worth today, right now. Since you borrow $80,000, the present value is $80,000. Okay. B says the future value is how much you owe 30 years from now. What is the future value? Okay. And we have to be careful once again. This is not, in this particular case, this is not an annuity. This is just straight up compounded interest. Okay? So in this particular case, 30 years from now, the future value is 80,000, which is the initial amount. Okay? So present value is really a way of saying initial amount. It is compounded. It is a 4% interest rate. It is compounded quarterly, so we're dividing by 4, and it's 30 years, so 4 times a year for 30 years. And let's calculate this with your calculator and see the scary number that comes out when we see how much you actually owe. So this is 0.04 over 4 plus 1 raised to the 120, because that's 4 times 20 times 30, multiplied times 80,000. So you, in 30 years, you're going to owe $264,030 and about 95 cents. And so this is a gigantic number, and it is pretty scary that you borrow this much now, and with 4% interest, wait a minute, I'm sorry about that, I made a mistake. Let's see where my mistake is. It says here compounded monthly, compounded monthly, not quarterly. So I have to change a little bit in my equation. So monthly, so not 4 times, but 12 times. So that's going to change the results just a little bit. Let me do this again. 0.04 divided by 12 plus 1 raised this time to the 360 times 80,000. 265,079. So let's correct this. $265,079.84 approximately. We're rounding to the nearest penny. Okay. Now note here that, again, this is a massive amount of money to owe, especially when you just borrowed a relatively small amount. So this is more than 3 times what you originally paid for. Okay. And one thing I want to note here, and this is what you owe if you make no payments. For 30 years. So if you paid nothing at all on your home on this particular loan for 30 years, this is how much you would owe when it comes time to pay up. In real life, though, no bank is ever going to allow you to do this sort of thing. No good bank anyways. So we'll go through the notes here. Most people do not save up that much money even with 30 years. So the bank creates a payment plan in the form of an annuity. So what the bank does then is it's saying, well, instead of paying nothing now for the next 30 years and then requiring you to pay this much amount 30 years from now, we're going to make you pay a little bit at a time. Okay? So we're going to make you pay some amount. So we pay monthly. And this is going to get calculated like an annuity. So the bank is requiring you to put money into an annuity in order to pay off this amount slowly. Okay, so remember the equation for annuity. This is the periodic number of payments times 1 plus R over K to the KT, all of that minus 1 divided by R over K. Okay? So this is the annuity that you're going to have to pay. Okay? And let's see here. What do we know about this? We don't know how much you're going to have to pay. We do know that the rate that we're paying at is the same rate that you're borrowing money from the bank, which is 4%. So this is really just a matter of fairness. If the bank is charging you this much interest, when you pay for it early, you should get the same amount of interest compounded monthly, because you're going to have to make this payment every single month. 12 times 30 minus 1. This is 0.04 over 12. Okay? And this is the annuity that you're going to have to pay them for 30 years. So this is an annuity for 30 years. So you're paying some amount every single month for a period of 30 years. And this amount has to equal what you would owe the bank. So 265,079.84. And when we solve this equation, we'll figure out how much you have to pay every single month. So I'm gonna do a couple things here. You see this, well, I'll just start typing this in here. So 0.04 over 12, that's this part, plus 1 raised to the 360th power minus 1 divided by 0.04 divided by 12. Make sure you put that in parentheses. And so I have R times 694.0494044. And I'm going to store this into a particular value here. So I just say this is stored into A. And all of this is somehow equal to 265,079.84. And then, of course, I'm going to divide both sides by this big number here. So I can go 265,079.84 divided by A. And that means R is approximately $381.93. Okay. So now one thing that we should see here is that if you pay a little bit at a time, if you pay consistently every single month for 30 years, you would have to pay only $381.93 every single month. If you don't pay anything at all ever, and then 30 years is up, this is how much you'd have to pay. And the amazing thing is that these two amounts here, the annuity that you're paying at $381 a month for 30 years, is actually going to grow you this much money over that period of time. Okay, so what you're actually saying is if I pay $381.93, if I take that money and I invest it into an annuity consistently, in 30 years, this is how much money I would have, and I would have enough then to pay the bank off. Okay? But the bank is going to want you to pay every single month in order to make sure that they're getting a steady stream of income. Okay, so that's the main idea here. Notice a couple other features that isn't really mentioned in the problem, but is also very very prominent and important, is that whatever rate the bank is charging you at, they're going to give you the exact same rate in the annuity that you're paying them back. Okay, otherwise it's really not a fair deal. Okay. All right. So this problem hopefully captures the two main ideas as far as the financial problems are concerned. One is just the straight up continuous compound for a period of time, and the other is paying at an annuity. And this is an example where these two concepts are very much related. And it's true for any type of payment plan, or whether it's a house, a car, or any sort of business loan. Again, if you have any problems, any questions with this, ask your teacher. Keep working on this, and have a wonderful day.